Hey, welcome to this another video of Internet of Things. This video will cover second unit, that is embedded system for IoT. Reference books for this unit are Internet of Things by Raj Kamal and Internet of Things System Architecture, Algorithm and Methodologies. So basically the contents of this video are introduction to embedded system, different components of an embedded system, basic microcontroller based embedded system, basics of Linux based embedded system, various embedded platforms used in IoT, and finally the understanding the various IDEs used for embedded development. So let's begin with introduction to embedded system. An embedded system is a computer hardware system having software embedded on it. An embedded system can be independent system or it can be a part of a large system. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific task. For example, fire alarm is an embedded system. Now, let us understand the characteristics of embedded system. It is single functioned. An embedded system usually perform a specialized operation and does the same repeatedly. For example, pager always function as a pager. Next characteristic is it is tightly constrained. All computing systems have constraints on design metric, but those on an embedded system can be spatially tight. Design metric is a measure of an implementation's features such as its cost, size, power, and performance. It must be of size to fit on a single chip, must perform fast enough to process data in real time, and consumes minimum power to extend battery life. Next is reactive and real time. Many embedded systems must usually react to change in the system's environment and must compute certain result in real time without any delay. Consider an example of car cruise controller. It's continuously monitor and react to speed and brake sensors. It must compute the acceleration repeatedly within limited time. A delay computation can result in failure to control of the car. Next is microprocessor based. So it must be microprocessor or microcontroller based. Next one is memory. It must have memory as its software usually stored on ROM. It does not read any secondary memory. Next is it should be connected. So it must have connected peripherals to connect input and output devices. Next characteristic is hardware and software system. Software used for more features and flexibility. Hardware is used for performance and security. Now, the different components of an embedded system. There are two main components of embedded system. One is application, second is platform. The first is application, which is software that provide the user with needed services. For example, to calibrate the amount of fuel to inject in a combustion chamber and to have proper ignition to get given torque request. Second is the platform, which is the combination of hardware and software that provide application with the resources it need to perform its task. Software can be broken down into three further components, namely the bootloader, operating system, and the system program. Now next is basic structure of an embedded system. which includes first unit as a sensor. It measures the physical quantity and converts it into an electrical signal which can be read by an observer or by any electronic instrument like a to D converter. A sensor stores the measured quantity to memory. Next is analog to digital converter. An analog to digital converter converts analog signals into discrete levels. Processor. Processor process the data to measure the output and store it onto the memory. Next is digital to analog converter. A digital to analog converter converts the digital fed by the processor to analog signal. And the last is actuator. An actuator compares the output given by DA converter to actual output stored in it and store the approved output. Next is the basic software structure. The bootloader here is a program to be executed at power up. It is in charge of initializing the hardware to enable the operating system and other system programs. Operating system is in charge of making hardware more user friendly, and system programs are set of the utilities that allow the application to access the resources provided by the platform. Next is the basics of microcontroller based embedded system. This consists of different sensors measuring different physical parameters, then signal conditioning, microcontroller, output interfaces and actuators. Sensors basically reads the physical phenomena and generates the equivalent output that can be fed to the microcontroller. But before that, we have to ensure that we should convert the analog signals provided by the sensors to be converted into a digital signals. For that, we require analog to digital converter or other type of signal conditioners. Then the digitized data is processed and controlled with the help of microcontroller. And if we want to trigger some output, we require output interfaces in the form of drivers, amplifiers and digital to analog converters, so that we can give signals to the actuators and we can monitor some process parameters. Next is Linux based embedded system. Today, Linux can be found in embedded system of many sizes, from mobile phones, home appliances, or vehicle infotainment to the international space stations. Many factors contributing to Linux popularity are: it is open source, so anyone can access the Linux source, study it, and modify it according to their specific needs. A very strong and committed community maintain and improve the Linux regularly. It is very flexible and support just about the any hardware architecture you can imagine. Because it is deployed in millions of devices, its code is constantly tested in many different scenarios. This means that its usage legacy is always becoming more and more robust. Next is it is supported by a huge ecosystem of softwares that consist of both runtime software, that is graphic libraries, networking stacks or device drivers, and development tools, that is compilers, debuggers or profilers. It is royalty free. This means that no payment is due to anybody if a product using Linux is manufactured and sold. This makes Linux very appealing for industries with a large user base such as consumer or automotive products. Linux was announced on August 1991 by then unknown Linus Torvald. Within a few years, it grew a huge user base and supporting community. Today, different kernel categories exist to reflect different maturity levels of code base. From an industrial perspective, the long-term kernel is particularly relevant. These kernels code bases undergo bug fixes for 2 to 5 years. This gives industrial designer confidence that the code in the device they are creating will be regularly maintained and fixed for relatively long period of time. This helps avoid early obsolescence. So today several kernel categories exist including pre-patch, which are pre-release maintained and released by Linus Torvald. Second is mainline kernel, it is maintained by Linus Torvald and it is where all new features are introduced. New line kernels are released every 2 to 3 months. Then next is long-term kernels are older release subject to long-term maintenance. Important bug fixes are applied to such kernels. Some of the examples of Linux-based embedded system are in-flight entertainment system. So Linux is particularly suited for in-flight entertainment because it is simple, not weighted down by accompanying program and easily adaptable to many environment. Next example is the cafe and bake shop. The screen displays the messages Linux produced during boot up. In particular, we can recognize a kernel panic as the kernel is not able to find the root file system. Next example is a gas station pump. The screen displays the message of Linux bootloader. This gas station is powered by Linux Ubuntu distribution with kernel. So now let us talk about Linux based embedded system components. An embedded system is composed of two main elements. First is the application, which is a software that provides the end user with needed services. For example, correctly calibrating the amount of fuel to inject in the combustion chamber and the proper ignition timing to satisfy a given torque request. Second is the platform, which is combination of basic software and hardware that the application used to perform this task. We can also consider the basic software as having three components: the bootloader, the operating system, and the system programs. Bootloader is the software execute at a power up to set up the hardware to run the operating system. Next is device tree, the tree data structure with nodes that describe the physical device in the hardware needed by the Linux kernel to initialize properly the device drivers. Next is Linux kernel, the operating system code providing all the service to manage the hardware resources. Now here is the reference hardware model of Linux-based embedded system. So this embedded system hardware components are RAM memory. This is volatile memory storing data and code. Next is CPU. CPU is a processor running software. Next is I/O. I/O is a peripherals to get input from the user and to provide the output to the user. Next is a boot flash. It's a small non-volatile memory needed at power up. Next is mass memory flash. It's a large non-volatile memory. Next is the role of an embedded system in IoT. So embedded systems are part of every modern electronic components. These are low power consumption units that are used to run specific tasks. For example, remote controllers, washing machines, micro oven, RFID tags, sensors, actuators, and thermostats used in various applications, networking, hardware such as switches, routers, modems, mobile phones, PDAs, etc. Usually, embedded devices are a part of larger devices where they perform specific tasks of the device. For example, embedded systems are used as network thermostat in heating, ventilation, and air conditioning. In home automation, embedded systems are used as wired and wireless networking to automate and control light, security, audio, visual systems, sense climate, change monitoring, etc. Embedded system will also be at a uh, for the deployment of many Internet of Things solutions, especially within certain industry vehicle and industrial Internet of Things, that is IoT applications. Major players in embedded systems are hardware and software deployment are aiming to bring this transformation into their products to take advantage of growing IoT market. The area that are going to transfer are real-time operating system, that is RTOS, and microcontroller and microprocessor, followed by memory footprint and networking open source community and developers. So my embedded system should perform a specific task. It should be real-time computing. It should have RAM and ROM. It must read input output. It should produce output uh, properly. Then it should perform timely task execution. So next and the last point is understanding the various IDEs used for embedded system. An integrated development environment, that is IDE, is a software that provides facility to computer programmer for software development. An IDE normally consists of source code editor, built automation tools, and debuggers. Most modern IDEs have code completion. Some IDEs such as NetBeans and Eclipse contain compiler, interpreter, or both. Others such as Sharp develop and Lazarus do not. The boundary between IDE and other part of software is not well defined. IDE are designed to maximize programmer productivity by providing tight-knit component with similar user interface. IDE present a single program in which all development is done. This program typically provides many features for authoring, modifying, compiling, developing, deploying, and debugging software. For example, Keel, Arduino IDE, MPLab, Code Composer, LabVIEW, Xilinx for FPGA, Micro C for Peak, Protis. So this is the end of the video. So thanks for watching this video.